One of the key things that we're going to be talking about here is SIS design and integrating the cause and effect diagram into the SIS design. And, it's kind of a little bit of a lesson, a little bit of insight into software design and how most software that we engineers work with is absolutely freaking horrible. Because it kind of ignores what you should be doing and replaces it with things that make the software developer's life easier. So what we're going to be talking about today, let me pop this open. So here at our Connexus website, this is the main Connexus website. You've probably seen it. I'm going to go into software. We're going to be talking about our Vertigo tool. But we're going to be talking about SIS design in general, but our Vertigo tool specifically. And if you want more information, you can get it all here, including brochures, live demo requests, pricing information, brochures, and so on. And if I go down here to trial request and pricing information, we at Connexus are very proud of our very low cost and very generous licensing strategies. So unlike other software vendors, we put the pricing and the details right here on our website instead of making you come to the salesman and get a hard sell. So also here, I can go under software and I could go to Connexus Integrated Safety Suite login. We are not some other people have like kind of remote access desktop software that they've been kludging together for 20 years and haven't really improved. Connexus, on the other hand, real live enterprise software with all the features you'd expect, including single sign-on. So I'm going to sign in with Microsoft. I've logged into Office 365, so it dumps me in directly. And I am going to be playing around with the facility that we're looking at is General Oil and Gas Operating Company, which is our fictitious company that we use to do demos and training classes. I'm going to go into the Texas City gas plant. I'm going to go into the separations area, and I am going to be looking at the Vertigo study or the SIS design that's going to include all of these safety instrumented functions. And what we're specifically going to be looking at is instead of, typically what you're used to seeing is kind of the SIS design phase where you lay out your sensors, your logic solvers, your final elements. You drill down into the details in terms of failure rates and common cause failures, diagnostics, whether you trip on diagnostics, external comparisons, all that other good stuff. But at this point in time, we're looking more toward the SRS phase, but we're going to actually back up and show how you can really make the cause and effect kind of a central hub in your design process, which is going to work more consistently with the way human beings actually think and act, as opposed to the way that the databases store the data. So here's my cause and effect diagram for this gas separation facility. It's not horribly filled out. Basically, I do most of my demos on Interlock 101, which is associated with the high pressure separator. And for some reason, I threw an extra valve in here for some reason, and it's got extra valve in the name. I do too many demos, and well, you add stuff for one demo and forget to remove it, and here we are. But I digress. Let me jump out of here and get back into the presentation where we are going to start. So once again, I gave this at a conference in Oman in February through DMS. So the topic of the presentation was enhancing SIS safety lifecycle efficiency through integrated cause and effect diagram functionality. And kind of subtitle here, where we're headed in our designs is to optimize safety instrumented system design using seamless integration. So as we progress as an industry, as engineers, we're always looking to make our work easier so we could get it done faster, but we want it done more accurately, and we want to minimize rework and monotonous manual tasks that actually end up leading into failures because you kind of I don't want to say you forget about, but you lose track of what you're doing because everything gets so monotonous. And this process, so kind of a little bit more background here. Connexus is also in the process of developing a management of change product, not because we wanted to do a management of change product, but because our customers like very vigorously demanded that we incorporate a management of change piece of software into our web suite because it connects seamlessly into our PHA product and all of the other technical safety tasks. But as I was developing the software or co-developing the software with my team, what we realized is that a lot of times, and this is going to be consistent for so many software applications in engineering, that the software developers are going to create a database or a data structure to hold the data about the task, whether it's an MOC task, whether it's an SIS design task, whether it's safety requirement specifications. They'll define the data structure, what needs to be in the data structure and in what format. And that's realistically the starting point to your software design. And then the software developers, most of the time, who have never done any technical safety tasks, which is not the case at Connexus. All of the software developers at Connexus are technical safety engineers first. They do these tasks. And as we were kind of going through it, especially our MOC tool, we started laying out some forms to interact with the database, the data structure. And basically, all that the form did was mimic the data structure and, turned our data record into a form that you fill out. And what we realized is that the way that the data is laid out in the database bears no resemblance to a rational human workflow. In a rational human workflow, you're going to input part of the data now, you're going to input part of the data later, you're going to take some data from this record, some data from that record, some data from that record, and put it all into one location. And you're going to want to view things differently than the data structure would imply. So you're going to store the data in one mechanism because it's efficient from a computational perspective. But when you're working with the data, you want to look at it differently. And what we realized for safety instrumented system design, the most ubiquitous, universal method for presenting a safety instrumented system is the cause and effect diagram. So we're going to talk about what we have now, but we're also going to talk about directions in the future. That was the purpose of this conference, was to talk about where industry is going. So this is part kind of an explanation of how to write how to do SIS design. It's part explanation of how our Vertigo software currently does it, but it's also a very good description of what we expect to see in the future with regards to how SIS design is going to happen. And the eureka moment that I had basically said, the cause and effect diagram is actually the central focal point for SIS design, not a list of safety functions. Well, a list of safety functions, which is what clause 10.3.2 would lead you to believe. Speaking of clause 10.3.2, for those of you that are not aware, I do a podcast that's available on Spotify. It's available on Apple, called the Connexus Functional Safety Podcast, where I walk through the IEC 61511 standard kind of one clause at a time. And I bring this up because I just finished, and I think, Chris, we just released the latest version of the podcast goes through the last 5 bullet points of clause 10.3.2. So if you want to hear me pontificate more and more and more about the contents of the standard and safety requirement specification, I recommend going to that podcast. As usual, it's free. You just need to go and get your favorite podcast player and sign yourself up. Okay, so on the screen right now, we have a bit of a cause and effect diagram coming directly out of Effigy. So I've already shown you this in Effigy, and I actually showed you how I generated that extra row with a new valve the last time I did a demo. But this is what it looked like before I messed it up with the demo. So what is a cause and effect diagram? So basically what we're doing is we're defining the relationship between hazardous events and safety functions, kind of at the big picture. But more specifically, when it comes to hazardous events, there are mechanisms to detect that the hazardous event is about to happen. Those are going to be the inputs. Those are the rows in my cause and effect diagram. The safety functions are kind of the actions that we are going to take to prevent the hazard from turning into a consequence. And the actions are the effects. Those are the columns. And then there's going to be a matrix essentially over here, kind of bottom right. Actually, I have my magical pencil. Right there is where our matrix exists that will convert an input to an output. And you'll see that we have a lot of mechanisms that are available in Vertigo, and a lot of mechanisms are used in industry. Sometimes we just use a simple X that says, if this input is abnormal, trigger this output. Sometimes we're a little bit more elaborate and we say, okay, well, this high level is going to close this valve. Sometimes we might want to go into a little bit more detail and refer to a note that explains logic that's a lot more complicated, such as this safety function is only active after 5 p.m. on Friday in odd-numbered months, is something that, well, it's kind of hard to put that into a cause and effect diagram directly, so you put in a note to explain the logic in a little bit more detail. So ultimately what we're doing is we are linking initiating events to SIS responses. So what's the big deal with cause and effect diagrams? If you go into clause 10.3.2 of the 61511 standard, it says that part of your safety requirement specifications needs to be a logic description. Now, there are a lot of different ways that you could do logic descriptions, from the most simple, which is just a text narrative. You write text describing what the safety system does, like a book. Or you could go into the most kind of detailed, esoteric, theoretical, where you're using binary logic diagrams, which is essentially writing a computer program in CAD that describes precisely what the safety instrumented system does. A narrative is going to be subject to the most interpretation. A binary logic diagram is going to be subject to the least interpretation. But the middle ground that most people, and I'm going to go out on a limb and say greater than 95% of safety instrumented systems, are going to be described with a cause and effect diagram. So why is the cause and effect diagram the logic description of choice in the process industries for the 1511 standard? Well, number one, it provides a clear, structured representation of safety logic. So it's very obvious what's happening. It's easy to read, yet it is very formal. This input goes to this intersection, goes to this final element. So it's very clear, very structured, and it's easy to understand and easy to interpret. So we're going to ensure that you have the proper hazard mitigation and system functionality. This approach is very fundamental. It's easy, it's intuitive to understand. It's ubiquitous. It's been used since way before the 61511 standard was invented because it's just such a clear approach. And it is a universal document that's going to be used for a wide variety of reasons. So a lot of people are going to use this document as the starting point when they're programming their PLC. But that same document then goes into the control room on a piece of paper, and people will use it as a reference to understand how the safety instrumented system works. It's used during management of change studies. It's used during PHAs to understand how the SIS is going to work. And a lot of times it's used as the basis of commissioning and validation, where it defines what the safety system is supposed to do. So during a validation process, you can kind of walk through the cause and effect diagram with a yellow highlighter. Not that I recommend that. I want you to write a formal procedure for validation, but I have seen people whose validation plan is simply to take a cause and effect diagram and yellow out the inputs, outputs, and intersections. And, if everything is correct, then the safety system should respond as designed. So very important document. Everybody understands it. Everybody knows how to use it. It's easy to develop. This is the ubiquitous tool. This should be what we use as a basis for designing our safety instrumented systems, yet we don't. Well, why don't we? Well, number one, a visual representation like a cause and effect diagram is kind of hard to draw from a programming perspective. Now, most of Connexus's competitors, you're going to simply see text-based forms using third-party tools that will basically take your database and automatically create a form for you that interacts with the database. It's really easy for the programmer, but it's clunky, it's slow, it doesn't match your workflow. You want a better tool. Honestly, you deserve a better tool. All right, so let's talk about challenges with traditional cause and effect diagram workflows. Most safety, and this is what I just got to talking about on the previous page, most safety lifecycle software out there is just forms. And those forms are going to be automatically generated based on the database structure. So the software is written to make the programmer's life easy, not to make the person who's using the software's life easy. The user interface is bad. So the software that's out there, for the most part, does not visually represent the data or the workflow. Also, there are a lot of manual data entry issues. So when you need to enter data into your software, if you're using a multitude of different tools, so I use one tool for my PHA, I use one tool for my SIL verification, I use a different tool for my SRS, I use a different tool to audit my SRS when I'm doing my validation process, you're basically recreating information during every step. The ultimate would be to have this done automatically. And when it comes to cause and effect diagrams, most of the time, we're still talking about Microsoft Excel spreadsheets. So we're going to hire an intern or a junior engineer whose job it is to look at those forms in the SIL verification database and convert that into a cause and effect diagram. Repetitive, time consuming, error prone. And then don't even get me started about keeping it up to date as you make changes to your plant. Your SIL calcs, your cause and effects in Excel spreadsheets are going to end up never matching. We have data silos. So between the HAZOP, SIL verification, and the SIS implementation, there's generally not a lot of automatic transfer of critical safety data. And that's something that a unified platform like Connexus Integrated Safety Suite, where you have all of these tools and all the tools work together and pass data back and forth, is going to reduce the repetition, reduce the errors, and reduce the amount of time that it takes to do your work. Change management complexity. So tracking, if you make a change and you're entering data in multiple locations, you need to remember where are all the places that I need to go change when this data point changes. And this can eventually have a large impact on safety and project timelines. So the amount of time that it takes to convert your SIL verification into an SRS is going to generate all kinds of delays. A lot of times you have inconsistencies because somebody fat fingered something. It's a 10 there. It became 100 over here, which also then even regulatory compliance risks if your data doesn't match reality. And let me tell you, some of the OSHA inspectors out there, it's very easy for them to say, hey, your document says one thing here and it says something different over there. Here's your $25,000 fine. So there's a lot of challenges in the current traditional workflow. So let's talk a little bit about an integrated approach. First off, when you're designing your SIS, you are going to hope for and want seamless integration between your SIS data and your PHA data and your ongoing maintenance data, so that when I enter in a tag number in the PHA, I want that tag number to cascade to my SIL determination, my layer of protection analysis. I want that to cascade to my SIL verification. I want that to cascade to my cause and effect diagram, and then my validation process even, all without me having to retype it. So I'm going to go ahead and jump into Vertigo here, or actually the full suite in just a second. But you can see that you can link, and there's the little link button that I'm going to show you how this works. You can link a safeguard to a Vertigo study. As a matter of fact, you can actually automatically export all of your safety functions out of our Open PHA tool into Vertigo all in one fell swoop, or you can link them individually, and you can forever go back and forth between your PHA LOPA study and your SIL verification. And the way that Vertigo works, you're cascading the data across. So you start in SIL verification, you move on to safety requirement specifications, and then you can even move on to maintenance and testing and other design tasks. So we started here in Open PHA. We cascaded through this linking process into our SIS tool, and we go all the way into the detail of the cause and effect diagram. So what we're trying to do here in this process before I jump back into the software is we're trying to eliminate redundant work, and we're also going to have a single source of safety data that's going to flow through all of the life cycle stages. So underlying everything, you have a relational database where if I change something in one place, that change cascades everywhere that you that you need that change to move to. So when you're making changes, those changes are going to be reflected in real time across all of the linked elements. So let me jump out of my presentation real quick, and I'm going to go back into my Texas City gas plant separations area. So I started the design of my SIS with my HAZOP LOPA. So I'm going to open up my working revision. And generally, you're going to do a HAZOP first. So here I've got a high pressure deviation in my production separator. And in this PHA, I might have put in a relief valve, or I might have put in a safety instrumented function. I might have put in a BPCS function. Here I have a safety instrumented function. So this is during the HAZOP, and I say over here under the LOPA required, yes, I want to do a LOPA on this scenario for whatever reason. There's a lot of reasons that you want to transfer from HAZOP into LOPA. And now when I go into my LOPA, you'll see that the data is linked. So if I make a change here to this IPL description in the LOPA, you'll see that that change also got cascaded back into my HAZOP study. So you change it one place in the data structure, and everywhere that data field is viewed, it's going to show up. Now you'll also see this link button here. Well, how did this link happen? I'll kind of show it to you for this BPCS function. So if I click on this BPS function, I can click here to say link the safeguard to a Vertigo IPF. When I do that, it's going to bring up a list of all the facilities I have access to. And let me just kind of select General Oil and Gas Operating Company, Texas City Gas Plant Separations Area, SIS, and then I can pick a safety function that I want to link these things to. Or those of you that are in the know, if I go to Premium Tools, I can say synchronize with Vertigo. Now I can basically, take everything that actually new study, and then I can basically say, okay, everything that is a SIF type, I can create a new Vertigo study, or I can update an existing Vertigo study. So I'm going to cancel out of there. I'm going to go back to my LOPA worksheet, and you'll see once this link is set, and when I click on it, it's going to go and say, okay, this is the information that I see for that interlock in the Vertigo study. Okay. And if I want to actually view it in Vertigo, I can click here. Now it's going to close my open PHA study. It's going to open my Vertigo study. Here it is in Vertigo in the SIL verification summary page. And you'll see over here these link to LOPA buttons. So I can break the link, I can synchronize the link, or I could just view. Okay, so when I do this now, I went back and I viewed the study back in OpenPHA. But when I click here, I can click on this synchronize link, and now it's going to show me the data in both OpenPHA and Vertigo, so in the HAZOP LOPA and in the SIL verification SRS study. And you'll see I've got some red lights telling me that some things are different between these two studies. And if I want to synchronize the Vertigo study with what's in OpenPHA, I can simply hit the sync button. But you cannot go the other direction. You cannot shove data from Vertigo back to your OpenPHA study. Why? Come on, people. Your open PHA study is a legal document. Your HAZOP is a legal document that's required for regulatory compliance. If you want to make a change to it, you need to get a PHA team together to agree that those changes are appropriate. So you don't automatically shove stuff backward into the HAZOP study. You need to get a team together and do it in the HAZOP study. But at least we'll tell you what the discrepancies between them are. So that's kind of the linking between the HAZOP, then to the LOPA, then to the SIS study. So when I look at the details of this, I can do all of my normal SIS design basis stuff here and look at the sensors, the logic solvers, the final elements, and so on. I can drill down into the details. But I also have the ability to look at this information in a cause and effect diagram format. And when I look at things in the cause and effect diagram format, I can grab the rich information from other parts of the study. So this level transmitter or pressure transmitter 101D, A, B, and C right here in the high pressure separator, when I click on it, I'm going to be able to look at the details. So now if I go back to this level transmitter, let me go back to the linked study just to kind of more thoroughly demonstrate what's happening here. If I go to SIL verification summary, I see that PT101D is one of the items that I'm looking at. So what I can do, let's say I needed to change the tag of PT101D to just PT101. Well, I can go in here and I can simply change the tag of PT101D to PT101. When I hit update, the tag number was changed here. And when I go into subsequent life cycle tasks, so if, for instance, I want to look at my list of sensors, you'll see that it's now called PT101. When I go into my SRS phase and I go to the sensor data sheets, you'll see it's now called PT101. When I go into the cause and effect diagram, on this row, you'll see it's PT101. So I made a change in one place and it cascaded everywhere because we're using that underlying relational database structure. Now, what didn't it update? It didn't update the HAZOP LOPA because that would be illegal. But if I go to SIL verification summary and I hit this, it will, well, here, I guess the actual sensor tag isn't in the HAZOP LOPA study, only the tag name of the instrumented protective function is in the HAZOP LOPA study. But you see the power of the relational database and the ability to cascade information from one task to the next, to the next, to the next. So let's pop back into the presentation. What are the functional capabilities of an integrated cause and effect diagram approach? So now I'm going to talk a little bit about what we're envisioning as a product roadmap and a plan for what we expect these tools to be able to do in the future. So if I have smart cause and effect diagrams, what our software literally does is it's like having a cause and effect diagram button on your keyboard, because once you enter the information for the safety instrumented function, the cause and effect diagram is going to get automatically generated from the existing SIS data. So if I go back into my Vertigo study, you'll see that when you're doing your IPF list, you're going to define a safety function in terms of defining what are the sensors, what are the logic solvers, and what are the final elements. And once you do that, you're going to have a list of all of the sensors that are in your study. So once you click on a sensor in your study, and I'm going to go ahead and change this back to what it was before. You can select something called an IPF group. So basically what you're doing is for every instrument in your database, you're going to assign what group does it belong to. Now, maybe you want all of your SIS instruments to be part of one huge group. Well, that's okay. A lot of people do that, but that might end up making your cause and effect diagram unwieldy to where you need to print out like 10 E-size drawings and you have a whole wall. Whereas we also give you the ability to kind of break things into smaller pieces. So the way we have the IPF's groups set up in this particular example is that we group them together by major pieces of equipment. So interlock 101 is associated with the high pressure separator, interlock 102 with the low pressure separator, interlock 103 with the gas compressor, 104 with the export pump, and I think 105 is the compressor utilities. So for every instrument that we assigned or that we created during the SIL verification phase, and we added to this page, it's in the database already. So when I go ahead and click on this cause and effect diagram for the very first time, all that the software does is automatically populate all of the sensors and all of the final elements. And right here, you see all items checked. That means that you're going to see every sensor and every final element that's in the database. It just simply draws you a matrix. Now, if you want to look at it in a more compact way, you can just show the inputs and outputs that are associated with one group. That makes it a little bit easier to view. And when you're here, instead of going into the compact view, you could kind of look at it in the detailed view. And you might want to, kind of make your screen. I'm at 150% zoom, so you might want to make your screen a little bit bigger. But now you have a lot more detail, or I can just kind of go back to the compact view so I could see more. You can lock your rows, you can lock your columns to help you navigate around, and you can even hide that main toolbar to give yourself a little bit more space. So just a much easier way to work with your safety instrumented system. And all of this, as I just mentioned, is automatically created. You don't need to start from scratch with an Excel spreadsheet. But if you want an Excel spreadsheet, go to Reports, go to SRS, go to Cause and Effect Diagrams, tell it what cause and effect diagram you want, hit Generate Report, and whoop, right there, we just generated an Excel spreadsheet. So if I go to my Downloads folder, double click, now all that stuff is in an Excel spreadsheet. No additional work from me, no retyping. You can do whatever you want with this type of format. So having all of the automatic generation saves you a lot of time, prevents repetitive work, and prevents errors that can happen when you move from one format to another. Okay, back to the presentation. And go back to the presentation view. So we're automatically generating the cause and effect diagrams. And as you make changes to your underlying data structure, everything in the entire workflow gets automatically updated. And we also allow you then to edit directly from the cause and effect diagram, which is a much more usable approach. So instead of having to go back into a definition of a SIF, click on a sensor and get the form, you can click directly on the sensor in the cause and effect diagram and bring up the related forms. Now, in the future, we're going to make those forms a little bit more powerful. So, and yeah, you're exporting all of the reports that you can imagine from a single database. This is going to make sure that we have validation. It's going to make sure that we have consistency throughout the entire SIS design. It's going to reduce errors before implementation. And because you can export reports in any format that you want, you're going to have audit-ready documentation. Now, why is this important? A lot of auditors, when they're looking at your SIS designs, they're looking at the IEC 61511 standard. They're looking at clause 10.3.2, and they're making sure that all of the information that's asked for is available. Well, you don't actually want to work in the clause 10.3 bullet point format. There are different people who access that data, create that data at different times. But if an auditor wants a report in that format, a couple of button clicks in the report generator section, and you've got that information to them in the format that they want. All right, so example workflow. Oh, here it is. So here's the piping and instrumentation diagram for the example workflow. So what you're looking at here is the piping and instrumentation diagram for that fictitious plant. And I have vessel 101, which is our high pressure separator. You could see all the information about the high pressure separator. I want to design my safety instrumented function. So my safety instrumented function, there it is, the one we've been talking about, pressure transmitter 101D, which is connected to USC 101, and those of you in the know that that should actually be UZC, a relatively recent update to the ISA 5.1 standard created this new Z designation, which I really don't care for. I mean, S is safety, so USC would be multivariable safety controller, but alas, no. Instead, we're going to do a multivariable SIS controller. So Z, when it's in the middle, stands for SIS, but it also stands for Z axis if you're doing three-dimensional control. So anyway, I don't necessarily like that, but it is what it is. I think USC would have been fine, but hey, let's be consistent. Everybody agreed, everybody voted. It's UZC now. And then for UZC, there is also a connection here to my shutdown valve 101. So if my pressure at this transmitter goes high, go ahead and close my valve. So what represents a good unified workflow? Well, before we do that, I'm going to keep, jumping back and forth. So once I'm in the Vertigo software, there's a portion of the software that allows you to import your documents. So my high pressure separator P&ID has this drawing number, revision, etc. And here is actually a hyperlink. So if I click on this hyperlink, I'm going to go into the Connexus server where the data is stored and pop it up. So we prefer not to store your piping and instrumentation diagrams. We have the capability. We prefer not to. A lot of operating companies are going to want to use a third-party data source like Documentum to be the single point of truth for all your data. And that's great because then we could just get a hyperlink out of that system so that we could pop it up when we need to see it, but we don't need to store it in our database. So that's kind of where that data lives in our software application. Now, the first step in SIS design is going to be the HAZOP, which is going to then trigger a LOPA. Some of you people do your HAZOP and LOPA at the same time in a single worksheet. So there are a whole lot of variations. Every variation you could possibly think of is going to be supported by the OpenPHA product. So when we went into our LOPA, we might have looked at the P&IDs and said, hey, there is a high pressure shutdown that is in my independent protection layers. And as I showed you before, you can press on the add link button, which will create this hyperlink, and you can link it to the Vertigo study. Or if it didn't exist yet, you would use the premium tools here to export all of the safety functions in a LOPA study into a Vertigo study as the starting point before you do your SIL verification calculations. So now I took my data from my HAZOP, it flowed to my LOPA. From my LOPA, it flowed to my Vertigo study for SIL verification. So you see right there that little link button, and that kind of shows you how it links to the actual Vertigo study. Now, I'm going to do my SIL verification design. So once I go into Vertigo, if you just transferred the data from a LOPA, then all you're going to get is the tag, the IPF description, IPF type, and the SIL target. You're also going to get an RRF target that you can't see on this page. You won't see it until you click into the details. But the rest of this information is going to be empty, and you're going to need to create it. I mean, that's all part of the SIL verification process. What sensor am I using? What logic solver am I using? How often am I testing it? That all happens in the SIS workflow. And the SIS workflow basically looks like this. So you're going to define what your instruments are, how often they're tested, voting arrangements, beta factors, all of those details we're going to look at. And that's all part of the SIL verification design. Once you're done with your SIL verification, the next thing you're going to want to do is you're going to want to develop your safety requirement specifications. So what is a safety requirement specification? And here is just kind of a view of the fact that our cause and effect diagram and our data sheets are linked together. So let me escape out of here and go into the software and drill down in a little bit more detail. So I mentioned that you kind of define your safety instrument and function during that SIL verification phase. You're going to define your sensors. Here you're making all those test interval, voting arrangement, online testing, offline testing, imperfect testing. You're making all those decisions about the safety instrument and function, and you do that for sensors, logic solvers, and final elements. And eventually your design is going to green light. So we're going to achieve the hardware fault tolerance. We're going to achieve the risk reduction factor, and we're going to achieve all of the attributes of the assigned SIL target. Okay, so we got a risk reduction factor of 50. Our target was 10. We achieved our hardware fault tolerance. We know that we met the design. In the SIS workflow, the next thing that you would do is develop your safety requirement specifications. So what you don't want to do when you're developing your safety requirement specifications is pull up a Word template and start typing the information out of this form into your Word document. That's time consuming. It's error prone, and it doesn't leverage the efficiencies of type it once and cascade it through the rest of the SIS lifecycle. So what happens in Vertigo is after the SIS phase, I'm going to develop my safety requirement specifications. Now, Connexus has an entire training class on best-in-class best practices for designing, for performing your safety requirement specifications. Okay, that's actually in the online training here in the Connexus Integrated Safety Suite. I might pull that up a little bit later just to kind of show you what's involved. But our best-in-class methodology for safety requirement specifications, or literally any type of specification, is general requirements, data sheets, and then in the case of logic solver design, a logic description. So all of the requirements for documenting what a safety instrument and function does falls into three categories: general requirements, data sheets, and logic description. Well, general requirements are basic, text. So I'm going to have an item number, requirement groups and subgroup, and then the requirement itself. So if I scroll down a little bit down here into the meat, you might have a general requirement that says, unless otherwise specified, the SIS logic solver is programmed for an off delay timer of 250 milliseconds to prevent signal noise from automatically generating a trip. So a general requirement is something that you're going to want to apply across the board for every device in the entire safety instrumented system. So you make it a general requirement where you write it down once and you don't have to keep repeating yourself over and over and over and over. The absolute worst way that you can generate safety requirement specifications is to take clause 10.3.2 of IEC 61511 and try to turn it into a fill in the blank form. Please do not do that. You're going to do all kinds of error-prone, repetitive work. You're going to waste a lot of time, and the end result is literally going to be unusable by any human being. That format is something that only an auditor can like. Please don't do that, and please don't use some of the honestly really expensive software that actually thinks that that's a good way to do your safety requirement specifications. Okay, so we have general requirements, and then we have data sheets for IPFs, for sensors, logic solvers, and final elements. Now, coming out of the SRS phase, or the SIL verification phase, you have defined to some degree all of your sensors, logic solvers, and final elements. What you need to do now is complete the data sheet. So coming out of SIL verification, you've got tag. You may or may not have service description. You're going to have voting arrangements. So a lot of the stuff that you see grayed out are the things that you defined in the SIL verification phase, and we don't want you monkeying around with them on this page because they're going to impact your SIL verification calculations. So if you want to make changes to these items, go back to the SIL verification page. But other things like what group, what is the model? Is it safety critical? What type of test am I going to do? What input type is it? Engineering units, set points, and so on. And for these data sheets, everybody wants something different. So if you go here to your study settings, I go to sensor, I can, add or remove things. So if I wanted to put an electrical area classification into my data sheet, I hit update. Now when I pull that data sheet back up, you're going to see that there's going to be a space here for electrical area classification. And again, the workflow cascaded all of this through. So I didn't need to create this form. The form was already there. I just needed to fill in the rest of the blanks when I get to the SRS phase. And now the last piece is the cause and effect diagram. Now, if I'm coming to the cause and effect diagram in a new design, I'm going to have everything, and let's say that I already did the SIL verification or the SRS data sheets. If I go here to my detailed view and I show hide the main toolbar, you're going to be able to see a little bit more. You're going to see all of that information that I put into the worksheets can show up in the cause and effect diagram. And now, instead of developing a brand new cause and effect diagram from scratch, all I have to do is put in information in the intersections of the cause and effect diagram based on my corporate standards for what my company wants to see in the cause and effect diagram intersections. So that workflow just saved us so much time in comparison to multiple different tools. And it probably also saved us a lot of time to some competing integrated tools, because most integrated tools can't do a cause and effect diagram because their programmers don't have the chops to do a graphical display. They require you to go back and fill out forms that are linked to the database, which is easy for the programmers, but hard for you, the end user of the data. Okay, let me go back to my presentation. So that's kind of the workflow of what we would expect. So kind of the summary and key takeaway from the presentation as a whole. Traditional cause and effect or traditional SIS design workflows and the workflow to develop a cause and effect diagram are inefficient and prone to errors because you need to take extra time and potentially make mistakes carrying data from one bucket to the next to the next. So every time you carry something from one stage to the next, you're going to lose data. There's going to be missing data. It's like buckets. When you hand a bucket to one person, you're going to spill something out. It's just nature. In order to improve what we're doing, lower costs, higher quality product, less mistakes, you're going to want to streamline the process with a single tool that's going to carry data all the way across. So companies are going to be able to enhance safety. They're going to be able to enhance compliance and efficiency if you use an automated approach. And if you have a single unified platform with graphical tools, that's going to give you smarter lifecycle management. Now, this is where I ended the presentation in Oman, and I did all of this in about 18 minutes. Instead of the hour that I've been talking so far. So with that, that's all I got. Let me go ahead and turn the floor over to Chris to see if we have any questions, or if you have any questions, feel free to jump on the mic and ask a question.
Yeah, right now I don't see anything in the chat. Does anybody have any questions?
It's a pretty straightforward product roadmap, and that's the beauty of the Connexus tools, is that even though we have online training, so right here, if I hit the training button, I can go into my courses, and Connexus does all their training here in the Process Safety Training Center. But I could go down here to using Vertigo, and I have a full training course on how to use the software, including this ragged looking dude here teaching the training classes. So even though training is available online, all this stuff is actually, I think, available on our YouTube or on our YouTube site. We generally find that our software is so intuitive that people don't even need to take the training. It's just kind of intuitive. All right. So did I see a hand up?
Mr. Edward, do you intend to make a connection with some bin software, bin plant, to manage the instruments, and you have it monitorized every time you move the instrument, or some kind of that bin software like Revit or PDMS, or
things like smart P&IDs, where you're going to have some of the instrument specifications already done in, like Total Plant has in tools where you could do some of the specification of your instruments. That is a very good question. Would there be value in bi-directional links between the Connexus database and an external database like a smart P&ID? The answer is yes, we can do that right now, but it takes a little bit of work. So if I go here, I'm a company administrator at Connexus. So when I click here, you're going to see we have this thing called API integrations. So Connexus has a full suite of application programming interfaces, And we use those application programming interfaces, and our customers use those application programming interfaces. And I need to do a webinar about these in the not too distant future. But if your smart P&ID software also has API integrations, then we will have the ability to do a bi-directional synchronization of our data, which just needs to be set up in something like Power Automate. So let me give you an example of that. One of our customers, a fertilizer manufacturer, Yara, they probably won't mind me mentioning their name. What they do is we have the ability to track testing data, but Yara doesn't manage the testing in Vertigo. They manage their testing in SAP PM. Okay. So all of the scheduling and all that stuff happens in SAP PM. But what they have done is they've used our APIs and SAP's APIs such that when a test of an SIS component is performed in SAP, the results will automatically get written over into this database. Right. So using those APIs, so you can always keep your data in the most appropriate best-in-class tool, is something that we have the capability to do. Absolutely. It's just a matter of setup, and we're working hard to try to make that the setup of the data transfer easier and easier.
Thank you, Mr. Adler. Great.
All right, my pleasure. Okay, well, I mean, hey, it's something that we are very proud of the software because it is so intuitive, so easy to use. I thank everybody for all their time and all their attention.
Thanks again, everyone.
Thank you, guys.
Thank you.
Have a nice day.